Okay, 4-6, direct variation. Direct variation is sort of a, I don't know if it's a weird thing, it's an interesting thing. It's like thrown into the middle just after you learn y equals mx plus b, and you know that m is the slope and b is the y-intercept. They throw this in every math book. In our math book, this is the equation they use. In some math books, they use this equation. In other math books, they use this equation. Okay? Now, if you look at these and you compare it to y equals mx plus b, what's obviously missing from these? What's missing? What do they not have? Exactly. They do not have a b. There's no plus b. You could put plus 0 if you need to get it in that form, but obviously 0 is the y-intercept, or you could say there's not one. So it's really easy to tell when something is direct variation. For instance, if you have an equation that says y equals 2x, and that's the end of it, that is direct variation, and that's what they're going to start out asking you. Is it direct variation or is it not? So that's direct variation. What if it said y equals x plus 2? Does that fit into any of these over here? No. So that is not direct variation. So the easiest way to tell is anytime there's a b. There's a plus 7, a plus 8, a minus 1. Anything tacked on to the end past the x. So this is direct variation. That's not. Now here's an example of the kinds of problems you're going to see where they're just asking you, is it direct variation or not? The way to find out is go ahead and solve for y. You need y equals something to be able to tell if it's direct variation or not. So we're going to solve for y. So on this one I'm going to go ahead and stick a 1 there so I don't confuse myself and go plus 1x plus 1x. Then I'm going to have y on this side. I'm going to rearrange so that my x is in the front. Is that direct variation? No. Why is it not? Because it has this part. That makes it not direct variation. Okay, let's do the next one. Minus 2x, minus 2x. So that cancels, that leaves y equals negative 2x, because the 0, 0 minus 2x is just minus 2x. There's no plus or minus thing, so yes, this is direct variation. This one fits into the formula y equals ax. Okay? Next one. Is it direct variation? Negative 4x, negative 4x. That cancels. That leaves negative 5y equals negative 4x. Divide by negative 5. Divide by negative 5. So y equals positive, because negative divided by negative, 4/5 x. Is that direct variation? Yes, because there's no b. Now, while we're here, let's talk about one other thing. Okay? Let's talk about it's called the constant of variation. So sometimes they're going to ask you, okay, what is the constant of variation? Well, we only have 2 examples that were direct variation on this page, and the constant is just the number with the x, which also is the slope. Remember slope? So constant of variation basically equals slope, the thing with the x. Those are really the same thing they're asking for. So here's what we've said so far. This equation is direct variation, and 4 is the constant. This equation is not, that should be an S, is not direct variation. Okay, here's your first part of video homework. You're going to tell whether or not it's direct variation. And then, the ones that are direct variation, you're going to find the constant. This is only part 1 of video homework. Keep going. Okay, graphing with direct variation. Some good things to know about graphing. It's the same graphing we've been doing. There's nothing different, except every single time you graph direct variation, every time it's going to go through the point 0, 0, or the origin. It's always going through that point. So if you are doing direct variation and you come up with some graph that's not hitting that point, you did something wrong. Let me give you some examples. One of these lines is direct variation. I can just look at it and know. The one that's direct variation is this one. Why? Because the graph is going through the origin, the point 0, 0. This one over here is not direct variation because it's not hitting the origin. Every single graph that's direct variation goes through the origin. Okay? Here's your last part of video homework. Have a lovely evening.